need to know how to do just redox reactions. Whenever something is reduced and something is oxidized, and in this particular case, it was a basic solution. So this is not electrochemistry. There is no cell. It's just a redox reaction. Okay. So chromium. What's oxidation state of chromium here?
3+.
3+. What's here?
2. Math is hard.
Okay. Take your time.
8.
6.
Good. Okay. So, is it oxidation or reduction? Going from +3 to +6.
Reduction.
Okay? Oh,
No.
you're losing electrons.
Oxidation.
Losing is oxidation. Okay, lead here. It's a tricky one. What's the oxidation number of lead here? Some lead has one oxidation number, another lead has a different oxidation number. But in general, like overall, it will be 2 times 4, 8. 8 divided by 3, 1/3. Okay? But like I said, it will be a mix. Some lead will be in one oxidation number, another lead will be in another oxidation number. Dr. Smee will love it in inorganic. I'm giving him his chance to teach, but here it's easy. What is it?
2.
+2. So you can see that +8 divided by 3 is larger than 2. So that will be the reduction. Okay? One is oxidation, one is reduction. Whatever is oxidizing is a reducing agent. Whatever is reducing is an oxidizing agent. So we put the species we have, and it's a basic solution. So we have to keep in mind that only OH minus and water would be nice at the end. Okay, so let's look again. OH minus and water. What is richer with oxygen?
OH minus.
OH minus is richer with oxygen, and water is richer with hydrogen. That's what we will use, kind of. Whenever we need more hydrogen, we will use water. Whenever we need more oxygen, we will use OH minus. Okay, so we have one chromium to start with. We have one chromium to end. Chromium is good. Let's go to oxygen. Oxygen, 3 oxygens on one side, 3 oxygens are on the 4 on the other side. Would be nice to add something with oxygen to the right. So oxygen rich will be OH minus. That's what I'm adding. Right now my oxygen is fine, but I also have 4 hydrogens here and no hydrogens up here. So you know my OH minus is not balanced yet. Because if I have to add water to the right to balance hydrogen, then everything is messing up, right? So let's think. I would say here and here. Those probably 2 places where you need to play with coefficients to balance oxygen and hydrogen. Chromium is good. Let's try not to mess up chromate or chromium 3+, chromium 3 hydroxide. So let's see. If we have some, like what combination would you suggest for hydroxide and for water? If we do something like 3, we would have 3 and 3, 6 hydrogens, right? 6 hydrogens now. It's probably not working. So if it's 3 here, we are making an odd number of oxygens on this side. Now, guys, just try different coefficients, okay? So 6 oxygens, but here it's 7. Oxygen is not balanced. Hydrogen is, but oxygen is not. So that's not the right number. Let's see. Let's maybe start with oxygen. That probably would be better. So 3 here.
You found 4.
Okay, let's do 5 and let's do 4. So 5 and 3 is 8, and here we have 8. We are good. And now let's look at hydrogen. 3 and 5 is 8, and here we have 8. Good suggestion. So 5 on this side and 4 of waters. All elements are balanced, but charge is not. Let's look at the overall charge here and overall charge up here. So on the reactant side, what charge do we have?
-5.
Good. And on this side,
-2.
-2. How can we make them the same? Where should we add electrons that are negative?
To the right.
How many?
Through 3.
Okay, cool. That's good. Now it's -5 and -5. It's good. Perfect. One is balanced. Everything, every element and every charge, everything is balanced. Let's move to the next one, and it's Pb3O4 goes to Pb4. Okay, so first of all, you can see that lead is not balanced. Let's balance lead. So 3 leads before and 3 after. That's good. Now, you can see we have 4 oxygens on the right and only 3 oxygens on the left. So we need to add to the left an oxygen rich OH minus, right? OH minus is richer with oxygen, that's what we need. And how many? That would be a good question. And whenever we added OH minus, we added H to the right. So water should be on the left. So once again, we need to play with these coefficients. Let's see what we have. 3 leads, 4, 5 oxygens, 3, maybe 2, maybe. Let's see if it's working, if it's 2. If we put 2 here, we are good with oxygen. Let's look at hydrogen. 2 hydrogens and 2 hydrogens. This one was easier. 3 leads, 4 and 1, 5. 3 and 2, 5. 5 oxygens, 2 hydrogens, 2 hydrogens. Good. Now charge. What's the charge on the left?
0.
What's the charge on the right?
-2.
Okay. So what would you recommend?
2 electrons on the left.
That's good. Perfect. So now with that we have -2 on both sides. Good. We now come up with 2 half reactions. Now we need to see that 3 electrons are given off, but only 2 are required. Now for the whole reaction, we need to balance these electrons to be sure that whatever is common is all is accepted. Okay, so I am going to multiply the whole half reaction 1 by coefficient 2 and the whole reaction half reaction 2 by the coefficient 3. That way we will have 6 electrons donated and 6 electrons accepted. So electrons in that case will cancel out. And we will add these two half reactions. So what do we have? 2 chromium OH3 plus 10 OH minus plus 3 Pb3O4 plus 3 waters. That was on the reactant side. On the product side, we will have 2 chromium O42 minus plus 8 waters plus 9 PbO and plus 6 OH minus. Okay, we know we are not done because we have the same reactants and products. OH minus and water has to be partially canceled, right? So we will cancel 6 OHs. 4 OHs will be still available on the left. We have 3 waters that will be canceled and 5 will be on the right. I'm rewriting it again. Now, hopefully it's final. 2 chromium 3 hydroxide plus 4 OH minus plus 3 P3O4 goes to 2 chromium O42 minus plus 5 waters plus 9 PbO. Okay? Okay guys, I recommend you to check again for everything. For balancing elements and charge. So we have 2 chromium, 2 chromiums. We have, let's say, 9 leads, 9 leads. Oxygen. We have 6 oxygen here and 4 here. 10 and 12, 22, 8 plus 5 plus 9. Yes, it's balanced, 22. 8 plus 5 is 13, and plus 22, yeah. Oxygen is good. Hydrogen. We had 6 hydrogens here. 6 and 4, 10. That's it. 10. Okay? Overall charge before and after. Let's look at that. What's before?
Minus 4.
What's after?
Minus 4.
Balance. Okay? If I ask you here, what compound is a reducing agent and what compound is the oxidizing agent? The reducing agent is oxidizing by itself, right? So this is oxidation. This is a reducing agent. This is a reduction. This is an oxidizing agent. Oxidizing agent and reducing agent. Question? All right, that's what you need to be able to do. Acidic solution means you can use H plus and water, and basic solution means you can use OH minus and water. And you should be able to do both. Good. If you have no questions, we are moving to the cell. Okay, we have